All right, everybody. So here's an activity that I'd like you to actually try on your own at home. You don't need much to do it, but what you do need is 100 pennies or any other coin. So if you can't find 100 pennies, maybe you have 100 nickels or dimes, or maybe you can. It would be ideal if all the coins were the same type, but if you can't, scrounge up 100 of one type of coin, then just use whatever you can find. So if you can get, 20 pennies and 10 dimes and so on, and get 100 coins essentially. And I think that most of you can probably scrounge around for 100 coins at home. If you're having trouble finding 100 coins at home, email me and I'll give you some numbers that you could work with. But I think most of you could probably find 100 coins. It would be ideal if they're all the same. Pennies work well for this, but you could use quarters, nickels, dimes, whatever you have. And again, try to have them all be the same type of coin, but if that doesn't work out, mix the coins and use a combination of different types, and you'll probably get pretty good results with that anyway. So the concept of this activity is to model the radioactive decay process. This is going to count as a lab. I know I called it an activity a minute ago. It will count as a lab. It's going to be a very simple one, though. It will take you a few minutes to do, though. So you basically take 100 coins, ideally the same type. You also need some sort of box or container with a cover. It doesn't have to be a box. It could be a jar, but it has to be some sort of object where you can lay all the coins out on the bottom of the container evenly without them piling up on top of each other. A shoebox works really well for this. Maybe some sort of Rubbermaid container or plastic food container that maybe you have in your kitchen, something like that. So anyway, if we follow the procedure, and I'll walk you through this, you're going to place 100 pennies in a large covered container. You need to have a cover for the container. You're going to place the 100 pennies in the container. You're going to shake the container several times with the lid on, of course. It's going to be a little noisy. Remove the cover, and then carefully empty the container on a flat surface, making sure the pennies don't roll away. And you're going to remove all the coins that have the head side of the coin turned upward, and record that number of pennies removed and the number of pennies remaining in the data table below. So basically, you're going to take your box, put 100 pennies in, shake it a few times, open the lid, and then what you're going to do is, instead of just dumping the coins out, this is where you need a relatively large box because you want them to all be flat and not piled up on top of each other. But you're going to remove the head side of the coin turned upward, and you're going to write that down in number of coins removed. And then you're going to record the number of coins remaining. Now, statistically, when you shake the box, if you have 100 pennies and you shake it a few times, roughly 50% of the coins should be heads up and 50% should be tails up. But what you might find is that doesn't work out exactly true. You might get times where maybe you have 52 heads and 48 tails, and so on. So you're going to do a shake of the 100 coins, and you're going to remove the heads and leave them out. And then you're going to shake it again. And each time you shake the box, you're going to have fewer and fewer coins to work with, because each time you shake the box, you're pulling out the number of head side coins up, out of the box. So each time you shake, you're pulling those coins out, and you don't put them back in the box. That's a common mistake with this. If you keep putting them back in the box, it's basically like doing the same thing, 9 times in a row. So you put 100 coins in the box, shake it up and down a few times, pull out the number of coins with the heads up, which you're going to write down here. The number of tails are your number of coins remaining, and they're going to stay here, or you're going to write them down here. Leave the number of tails up in the box, put the lid on, shake it again, and repeat the process. And you're going to record the number of tails. The number of heads are the ones that you're removing. You're going to write that number down there and actually physically remove those coins from the box and don't put them back in. And then keep working your way down. okay, and record the number of tails that you have, the number of coins that are left in the box, the number of heads that you've been removing each time. This is a good model of radioactive decay and how it works. Then it's going to ask you to make a graph. Now I know that you can't write on these kind of PDF files. So what I did was I created a spreadsheet, and here's the number of shakes, 9 shakes, number of coins remaining, number of coins removed. And I just made up some numbers just so that the computer had some data to work with to make a graph. These numbers are made up, they don't mean anything. So put your numbers over mine and replace my numbers, and as you do that, you should get the graph of your data appearing here. So this should automatically generate the graph for you. And then there'll be a Google document with just a couple questions to answer about radioactive decay. And here we can see the radioactive decay curve for carbon-14. So you need to find yourself some sort of box or container. You're going to have to try to find 100 coins. Again, it's ideal if they're all the same type of coin. If you can't make that work, mix the coins together, combine nickels, pennies, quarters, whatever you have around. If you still are having trouble finding 100 coins, then let me know and I'll just send you some data that you could work with. But I think that most of you could probably scrounge around and find 100 coins in piggy banks and under couches and whatever. But if you're having a hard time, let me know. And we'll talk about this more in a later video, but this will be a good model for this radioactive decay concept. Okay, try to answer the 2 questions, and that would be it for the lab for this week. So that's it, and good luck.